Says two.
Looks like something should do.
Yeah.
All right. Double check. Awesome. So yeah, a couple starting kinks, but we thankfully have a space that is not the library. Yay!
Hey.
Hello. We'll still have some people floating in.
Huh?
Still have some people floating in for a little while yet. Always weird moving to a new space. So actually, I typically don't do this, but for people for posterity's sake, we are in Tops, and if you guys want to say anything about Tops, this is a wonderful space to be in after the Iron Yard here.
So your Tops, we're a card trading company. We have like Walking Dead, Bonds, Huddle, some sport titles, some entertainment titles, and our backend is Python. So we're looking for talent. So any of you interested, please let us know. We have a hard time finding talent in the market.
Definitely offering space and hiring. So, diving right into it, just wondering how many of you have used Docker before? So most. I do not purport to be the authority on Docker. So if I mess something up or you guys know a better way of doing something, blurt it out. In the meantime, can go ahead and get started with the Python specific aspects. I actually started using Docker at Disney for a couple projects, and we've rolled out a couple of high workload projects with it. But what my favorite thing so far working with it is that it is a virtual env on steroids. Even if you're not familiar with virtual envs themselves, if you want to go in and try, personally, I think it's the best way to go in and try a future version of Python just to see if your application is going to work with it. Because when you have your Docker file, all you do is you change, if you're just pulling in from one of the standard Python repositories, just change it to release candidate 3.7 and just test to see. This one's going to be a little less structured than normal. However, I would love to just kind of play around with the release candidate version of Python. Actually, I didn't ask this. Who has never actually used Docker before? Okay. This is going to be a lot of fun. I love when we have a mix of people who are really knowledgeable and people who have no idea what is going on. So yeah, we'll play around with Python in a Docker container, look at building a very simple Docker container to wrap an application, and see about deploying it on ECS, which I personally have never done, although this weekend I did actually replace a 2-year-old Flask application REST API from a Microsoft Azure. You will run this on Python 3.4 into a Docker container that I actually just got up and running fully last night. So yay. Let's dive in. So, Python, like a lot of languages, has official Docker repository. Well, has official Python repositories on Docker. I think it's just hub.docker.com. All right, and zoom in a little bit. And I think they are all under the root Docker, so you don't need to prefix it with anything. Just search for Python. Welcome. Yeah, you come right out into the space. Well, let's just do this. Yep. So you have your choice of Python. Like I said, we can take a look at this a little later. The release candidate 2 of Python 3.7. I honestly have no idea what is in what new features are in 3.7, but we can test them out if we want. And you have all sorts of different flavors that you want on here, going all the way back, at least on the main builds. Actually, thankfully, they don't go too far back, just to 2.7.14. All right. So, for the people in here who have never used Docker before, or actually, would anyone else here like to explain what Docker is? If I would like to try not to capitalize on the meeting.
So, Michael, I have a question, because it's been explained to me a couple of different times. So I've downloaded Docker and I've attempted to use it like in a couple of different ways, and it's been described to me as like a virtual environment, sort of, but something more complex than a virtual environment. What do you have to say to that?
So it's, the way I've understood it is it's kind of it's not a full-blown VM, it's more like an isolated process. So it's like a VM in the sense that it doesn't really interact with anything outside of its little box.
Mm-hmm.
But it's not a full-blown VM because it's not having to emulate all of the resources of the computer. It's using the host computer, but it's own space.
Right. If anything, it's the opposite of what you said. It's actually less complicated than a VM because a VM has to virtualize the entire hardware environment, whereas Docker doesn't virtualize the hardware layer at all. So if you virtualize the hardware layer, you can run a totally different operating system. You can run a totally different version of the kernel. You can do a lot of stuff. With Docker, you can only run the same operating system that you're running on top of, which is going to be really Linux. I mean, Docker on Mac is actually running in a VM in Linux, so it's Linux. And but it still gives you same controls as in a VM, where you can control how much resources it gets, some amount of process isolation, but not completely isolated either, because you can still interact with the file system and other things, and you can segment networking, et cetera, et cetera. But it's really a really old concept with a little sugar on it. Because really, it's chrooted jails or chrooted root shells, and then they added a little bit of C groups onto it. So basically, they added a little bit of controls. They added some more controls onto it, but it's a pretty old concept made anew, and then made a little bit more accessible and portable, and packaged, so it could be given around to people and stuff like that.
Makes sense, thank you.
Yeah. And one of the beautiful things is, rather than trying to share a VM, as long as you have the base package Docker installed on whatever machine you're running on, you just share a Docker file, and it will build it for you right there.
Okay.
So you can either download the pre-built image directly, like what we're going to do with setting up our Python build, but then to build that new container, we can. If I give you the Docker file and you run Docker build with this Docker file, it will build the exact same thing that you can run on your machine.
Yeah, and it's worth pointing out by convention, but not by technical limitation. It's usually one per application, whereas virtual machines usually you run your whole tech stack, all your applications. Whereas in Docker, they encourage you to develop singular application containers so that they are small and thin, so you can either trade them around by sending people Docker files and then they can transfer the pieces they need or the whole image, so you don't end up with, multi-gig, terabyte images.
You can build or run a container locally and just open up your web browser and connect via the port number if you make a REST API publicly accessible from the container, or you can have your different containers talk to each other, like you said, application specific. So you can download a container that contains MongoDB, and you have another container that contains your application, and they will talk. And then once you uninstall, or not really uninstall, once you just remove these containers, then you technically never did install MongoDB or the application on your computer, so there's no cleanup, which is really nice.
So I guess you don't have to worry about like the flavor of Linux like at all, like jumping machine to machine, because you're deploying it at different machines. I never thought about that really.
Yeah, the kernel version.
Yeah.
If you have anything that interacts at the kernel level.
And the version of Docker. So that's the fun part, is
That
that
too.
it's not as portable as the VM. And in a way, because of its size, it's more portable.
Right.
But it has more dependencies on the system, because now you can align the version of Docker, maybe. There's obviously compatibility sets, and the version of the kernel, and et cetera, et cetera.
Those restrictions give you much better performance than a VM.
Yeah, obviously.
You wouldn't want to interact with the file system too much in a container.
You can reach out and interact with it, but you typically don't.
Well, it's a weird double-edged sword, and I'm actually really interested in your experience on it. But the problem is that they've gone through a couple of versions of their own file system, and so when you interact with the Docker file system versus the external file system, if you have heavy I/O, you actually want to do it externally, because if you do it internally, they have a habit of crashing. So it's sort of like if you have a database, which in general Docker says just don't do it, because really it's the I/O issue. They're saying put it on the external file system.
They use the host.
Yeah, because the AUFS is, I don't know. They've gone through a few. I don't know.
Well, with a database, you want to do that anyway, so that the data is not ephemeral.
Right, but then that's a little ironic, because a lot of people use Docker as like a deployment, and you may want to have the default state to your database. So now you've got a script level thing, and that may or may not be the best. I don't know. People have opinions.
From a development standpoint, if you just have your application in one Docker image and you have your files, like either static or your database or whatever outside of the container, it makes it really easy to just deploy it and use whatever existing infrastructure you have that contains your data, be it on S3 or MySQL, wherever you're going to have it, because it's completely separate from your application.
And it means you can update the code without touching the Docker image.
Well, you can update the code outside the Docker image.
Depends on what the application is.
Fair.
Yeah.
Right. Some
If the application is Unicorn.
sometimes I actually recommend to keep your code in the Docker container, because you're using Docker as a deployment method. And then other times it's recommended to keep your code outside of it, because then you get to flexibility and you're using Docker as just like a head for the app. Or you can simplify that and say, where do you put your config files for the app? You put it on the storage, well then it's not portable. Or you put it inside the container, but now it's not mutable. Or it's elusively mutable too, because that's another fun thing, is that you put things in the container, it's semi-ephemeral, meaning if you don't commit the changes to the image, next time you reboot, it's gone. So you think you're making changes, you are making changes, but on reboot they disappear. So,
Which could be the desired behavior.
right, which could be the design or could be terrifying, because you don't know until reboot time everything you've been doing for the past 5 years is not really there.
That's something that didn't happen.
Yeah, no. I have to explain it to these people, because they think it's a VM, and they're like, "But I wrote this stuff." I'm like, "You should copy that stuff."
I know personally for me, and this might not be best practices, but I always keep a couple different versions of a Docker file. So if I'm running something locally, I'll have a dockerfile.local that is never intended to be used in production. I'll just keep that regular Docker file, and it will have say env flags or point it to some different Docker container or a local backend that is not production, and I'll try to keep those in the same spot and more or less identical beyond what differences they need.
Cool. Show us cool stuff.
All right. Oh, actually, something interesting that I did find when I was we pretty much just used Macs at Disney, but when I was testing out this application, I was developing it on both this guy here and my desktop computer at home, which is a Windows computer. And when you actually go for debugging, when I went into the container, it wasn't Windows inside the container. It was Linux inside the container. And I don't know. I highly doubt that they just took all of the Linux things and did that virtualization, because there really isn't virtualization in modern Docker, or if they were tapping into the Linux subsystem that Windows now has as of the fall Creators Update. I'd be interested to actually look up and see if they're leveraging that.
The latest version of Docker, I believe, does tap into the Linux subsystem. The latest version of this.
I'm so happy that I can use Linux on Windows. It's so nice.
You can run any of your Linux programs inside of a Docker container. Even the desktop.
It's so nice. Although you can actually, as of 2016, you can also get Windows-specific containers. I don't know what it would be like to deploy or run the Windows Server 20-something on Mac. I'd be really interested to see if you enter the container. But once that is installed, we can do something like pull Python 3.6.2 is the current version. And we can just do Python because the default prefix is library, and it is a high-level Docker container. Conveniently already on my computer. And for the purposes of playing around with Python, one of the best commands I have found is interactive mode. This -IT, I for interactive, and T for tag. So we use our container tag just like we have up there before, and then we give it a command that we want to issue. If we didn't have the I interactive flag, it would just say, "Hey, I've already run bash. I'm gonna exit out of it." But because we have interactive mode, I am now inside the Docker container, and I could do that, and we're very clearly inside. There's the root directory of the Docker container, which is running Linux on Mac, which is all still Unix, so yay. And once inside, Python 3.6.2. And I can verify that because we have formatted strings, which, please, everyone use formatted strings. They're amazing, as long as you can get Python 3.6 and above. And then I think let's just exit. There we go, and we're back out. So it's a lot of fun doing this with pre-release candidates because they're, like I mentioned, when you're done with a container, just remove the container. It didn't do anything to your system. If you really like Anaconda or Virtual Env or pipenv, you're gonna feel right at home with Docker. So that's going into Docker containers. We can do something debugging in it later. Well, first off, let's do a little bit of setup. I'm just going to create a new window, a very simple Flask application that just, when you go to the root, it says hello world. Everyone's favorite bare bones Flask app. And just go into desktop.
Are we able to use one of the Wi-Fi?
Oh, yes. If you guys want to pass this around, this is Top's guest network. It does not appear when scanning, so you have to do join different network, type in the SSID and the password, and you'll be online. So that will make the rounds. Visual Studio, new file. So, super bare bones. Port, I think all we need is Flask. And yeah, we'll just use, I think we just need Flask. Let's see, app equals Flask. Let's see if I can remember this just off the top of my head. And it doesn't know it's a Python file yet. All right, I think that is it. So let's go ahead and do just server.py. There's my formatting. All right. Okay, so we have a super bare bones look at how amazing Flask is because of how short the Hello World script is, for better or worse. But if we go ahead and run this, and let me just double check that we have Flask on my main laptop here. Yes, I just saw it scroll past. Oh, let's see. Rather than exporting Flask up, there's one other thing we got to do here. If name, like our traditional if name equals main, because I'm not going to remember how to set the Flask app environment variable. Just do that. Or maybe just port 8000. Hopefully that will do it. So, already in Python server.py. There we go. Perfect. New window. Localhost 8000. Hello world. Super simple, bare bones Flask application for the of having something interesting. Now, we have there's a couple things that we need to do. First, we're going to make a Docker file. We're going to have it pull that Python container that we went into earlier. We will install our pip. Well, we're going to make a requirements.txt file for our pip requirements so we can install Flask. And then we will tell it to run server.py, and that should be it. And we'll also need to expose port 8000 because all ports are closed by default on Docker applications, Docker containers. So, first things first. Requirements.txt. Flask, and if I wanted to be really thorough, I could scroll all the way back up here, say that Flask is version 0.12, and then if we use the tilde equals, it will do something like version 0.12 and just bump up the minor version number. If we just did 0 point nothing, it will just keep bumping up the minor version number as opposed to the the patch version number. Or you could do equals equals for it must be exactly, or greater than, or less than or equal. All sorts of great pip stuff. But I personally prefer tilde equals that, so it will push out non-breaking bug fixes. So that's all we need in our requirements file. And now we come to our Docker file. Has no extension, but it's a Docker file. So the first thing we need to do is tell it which container we're going to build off of. I personally have never actually created a Docker container that isn't built from something else. Typically, you would at least say, I want to use this version of the Ubuntu base operating system internally. At least that's what I have seen. For us, if we want to get Python pre-installed, we can just do from that same container that we pulled from earlier, Python : 3.6.2. Next up, now remembering how much more we actually have to do in here, I think it's just 2. We can set the working directory just in the root, and then just Dockerpy, same as the folder that we're in. And all the code is just, and we'll just put our code in there. Believe we copy from, we can copy everything, or we can copy specifically just the requirements.txt file or server.py. We don't really have that many files, so we can just copy everything in our local folder and put it into our Dockerpy working directory. Then we run a command. So we say run, it's going to be bash. No, yeah, it gets run by bash. Pip install from our requirements.txt file, which got copied in up here. Yep. And lastly, I've seen 2 different things that you can do. You can either run your final thing, or you can use exec. From people who have used Docker in the room longer than I have, I would love to hear your thoughts on it, as to what you prefer to do for the here's what I use to run my actual program.
I think we've agreed with the Docker expert.
Well, one comment I will make is that you'll see that oftentimes in the run statements there'll be run-on statements that, because each one of those lines creates a layer of the file system, and essentially you don't want to create too many. So oftentimes you'll have a single run command that will run a lot of things at once, like a lot of scripts.
Yeah.
I mean, typically I think we
Backslash and then continues.
Yeah. Run or exec. Typically, actually, we just kick off a script that's in the container, and then that runs whatever. So that way, definition's not in the Docker file. So we don't want to modify the Docker file so often as we modify the actual Docker container. So basically, we have a, whatever it is, a supervisor or something. We have some sort of init script inside of the container. Really execute directly in the Docker file.
If I remember correctly, the difference between run and exec is, I believe this is right. If you run the Docker, if you have the last command in the Docker file is run, for example, and then on the command line you use Docker run to execute your image, any additional command line arguments will be applied to whatever you're running in the Docker file. So if your run is with bash, in the Docker run command line, you do ls as an additional command line argument, and that will result in bash ls, because it takes that and appends it to the run. Whereas exec doesn't actually run your Flask application. It's exactly what it is. As a development environment, it's a good bash.
Yeah. Welcome. All right. I have seen. I definitely have seen in my projects. I have used the same kind of run this file that runs everything else. I have yet to do something that isn't a Python file, but or I'll run this Python file. So run bash to run a bunch of different things on startup. If we want to do that here, we could take this out of the file so that if we want to work on that, that's fine. And have a, I'll just call this run.py. We do from server import app and then just do that instead. That's also perfectly valid. The same kind of thing with the setup.sh sort of files.
Well, typically I meant that we typically run some sort of daemon that will have some rules about kicking the application back off again if it dies or something. So I mean, depending on how you're monitoring, you may reboot your whole container, or that may be a terrible idea. So you run supervisor D or something like that, so it keeps the app inside your container.
Cool. I have not gone that far down.
Yeah, I think people, you can do the same thing with Upstart or whatever. I mean, you can do something with built-in stuff, but I think a lot of people like the supervisor.
So let's quickly get this running. Let's see. Yep, Python, run.py. It's possible to do more variable-like assignment in these Docker files as well. So these Docker files also have support for doing something like this. I don't know why, but people seem to like this at the bottom for whatever reason. I have absolutely no clue why, but I've seen a lot of people do that as well. It really shouldn't make a difference. But I believe that's all we need to go ahead and run this. So first things first, build it and let's, so we build, it will look for the Docker file in the current directory and let's tag it as, well, Dockerpy. By default, it gives it the latest extension as well. Running. We are, if we didn't have our initial container, it would start with the pull. Right now, it's going through the pip install. I just realized something that we didn't do, and this is actually a good teachable moment. I didn't put the port. I didn't expose anything, so this is still blocked off to the outside world. Actually, let's go ahead and, yeah, let's do this.
Put it after the pip install, you get to see caching come out.
That's a good point. I was about to just do, let's do best practices kind of here. So we'll do port 8000 because it's running on 8000. And if we go ahead and rerun this, and it's going to go ahead and step through that. While it's doing that, it should have, yep, there we go, using cache. So for every single command that gets in your Docker container, it will create a temporary container at that point in the run. So if it go the next time that you try to build your Docker container from your Docker file, it will go ahead and check each step to see if anything has changed. And if it hasn't, it'll just move on to whatever was the next Docker image, cached Docker image in your setup. So if you have something that takes a really long time, like your dependencies, and you just changed one line of code, it will go ahead and just say, hey, I have a container here with all of my dependencies already installed, and I'm just going to go to that one. Here's where you, and this container is where you copied in your code, boom, and go from there. So rebooting, rebuilding your container seldom will take as long as it did initially. Especially, actually at work, I had one container whose dependencies took 40 minutes to download and build. So Docker was a big help there.
That's our VirtualBox environment. We try to never destroy it ever. Can't wait till we move to Docker.
I'm so glad that. Oh, yeah. We really get to use whatever we want at my work, and I'm so happy as long as it is on AWS. That's their one limit. All right. So if we go here, can't connect the server.
So shouldn't run only be used for build steps?
That's what I was. I've only seen it used like this for build steps. Personally, when I get down here, I'll use something like exec or entry point.
Yeah, entry point command allow you to specify the startup command for the image.
Yeah. And so I'm wondering, given entry point, because I don't see entry point like this, I tend to see it more in this kind of array-like syntax. So I'm wondering if that will be better in this case. Oh, another thing. I'm just going to go ahead and move this up here. Another thing that I have found is when there's two ways that I see Docker containers typically, or Docker files typically organized. One is, here's everything that makes logical sense when building a container, and then I'll see here is I will put up top I will put my from, because you're almost always building from another container, but then they will be ordered according to things that are least likely to change. So if you have a really hard, if you know you're going to have certain dependencies that are always going to be installed, then you might do that. If we were to build this file like that, we might instead do copy requirements.txt and put it into, I think workdeer should just put it into the proper directory. We might just do, I'm just going to have I'm going to copy in my requirements.txt file, and then I'll pip install it. That way, when I make changes to my code, it's not going to go reinstall all my pip dependencies unless I add something new to the requirements.txt file. And if you're doing something like that uses sklearn that you need to compile for whatever reason, that can also save you a lot of time not having to wait for pip to reinstall every single time you try to build.
So the copy does some kind of fingerprinting to determine if you finished or changed the file.
Mm-hmm.
So it will automatically pick up new requirements.
Exactly.
So
Yeah, I believe it does some kind of checking, like a file hash or folder hash. It magically knows when something changed from when it was last built. So I believe I can still do just copy everything back in. Let's try this again. So we'll go back through, install pip requirements. Let's wait for it to complete. There we go. Okay.
now you do Docker run, right?
Yep. So, yeah, that's what was happening because it was running and it never
Yeah, because
quit.
otherwise the build would never finish.
Exactly. So, just very quickly, let's say I have now changed my file. I added a new line. if we go back in and build this, it's already done because we separated out the part where it copied in the requirements and installed as its own intermediary cached layer.
So here, can you add another requirement?
I can. So, super quick requirement. Keeping with the Flask thing, let's do Flask cores. Actually, it's just this. And I do not remember what the appropriate version number might be. You can tell I've done a little bit of Flask.
303.
Yeah. Same thing, I can just do tilde equals. If we go back and build this again, it detected a change, and now it's reinstalling the pip requirements. So, your boss's favorite time hack for not having for you to be more productive. And there we
I am
go.
the boss, it's already making me happy.
Probably I notify actually.
All right.
So
So,
it's 95.
yeah, it probably just MD5. All right, so we have a container that's built. Let's see, I don't remember if it's Docker list or Docker ls, or it's Docker images. There we go. So these are all the images that we have on the computer. Here's the one that we just built. It gave repository Docker Py. We didn't give it a tag, so it automatically tags it with latest. If you don't give it a tag, it just assumes it's that one. Created 8 seconds ago, and with everything included, 700 megabytes. All right, so now we can do Docker run. We have to specify our tag, or well, the container that we want, and if we just leave it at that, it will run. Well, actually, let's see. So it will run, and if I go back to my website over here, it shouldn't be able to connect, because even though we explicitly exposed port 80 in our Docker file, we still have to expose it when running it. And in this case, it ends up looking like this, because even though we expose something internally on the container side, we can still remap it to a different port. So if internally, if it was on port 80 for production reasons, or well, you should never do that in production, but I digress, we could remap port 80 to port 8000 for local testing. But it's 8000 internally, and we can just map it out to 8000 externally. Now it's running. Can go back. Dang it. All right.
Yeah, this is as far as I got when I was trying to Dockerize my Python application, so I'm just to see how you solve this one.
Okay. Let's see if I can remember.
Anything? You get anything? Expose the port in the Docker file.
Yeah.
Still can't.
Build it. Just back up 80.
Frames console, make sure it's running.
Well, that's what this message is here. We can.
What IP address are you getting on your Safari?
Oh, that's well.
Yeah,
Yeah, that's interesting. I don't know. Yeah, that's really. Oh, I remember what happened because it said so. I just opened this page by going to the IP that it says it was broadcasting on, which is 0.0.0.0 for allow everything. That needs to get changed to localhost.
Yeah,
Yay!
let's restart the Docker.
Oh, yeah, that's right. Oh, so, yeah, so let's do that. Now we reload.
Yeah, I was like, I didn't know.
Dang it.
So it depends your Docker machine. Is it localhost or sometimes it listens to 192.168.99.100.
It should just be localhost.
You run Docker PS, it tells you.
006.
This is literally why I'm here tonight. I want to see something wrong so I can go back and solve my
All
problem.
right. Well, as any experienced programmer will do, we go look up our previous code to see how we solved it back then. And I don't mind putting this on the stream because this is open source. Yay, open source. So at least in here,
Oh no, I know your password is password.
Dockerfile example. I'm not going to open that one up because that actually contains the URI. For the purpose of just keeping my sanity, I'm just going to copy this. So it just explicitly says it. And quick look at our file. We expose.
Because you changed the code, you have to rebuild the image. Copying the file into the image.
Since the code changed, you rebuild the image, but I changed the code and not the requirements. Or actually, it's going to have to rebuild because I just took out the Flask cores thing anyway. Oh, that was the other one I was looking at. CMD for launching, in addition to entry
The one
point.
thing he's talking about is entry point. Entry point allows you to pass in additional inline parameters.
Yeah,
But both of them should function for your purposes.
yeah. Like it's
I mean, for the sake of consistency and pulling one more thing out doesn't hurt.
no, it certainly doesn't. At least try it.
You can rebuild the image anyway.
Yep. So let's try just CMD, see if that does anything. There we go. Executable not found in path. I have never seen that one before.
Does it want the tag lines? Does it want you to run it before the run?
Well, I don't think
Do you have the invocation in the other?
I have it in my history. I did. The port was first, and I don't even think I included T in there, so it might just be the tag at the end. That looks better.
We're learning together.
We are. Hey! Yay! Okay, so I'm
Wait.
curious to see if going back to entry point, it could have just been calling it.
Entry point command parameters are not.
All right.
Yeah, but you didn't rebuild.
This is what. Yay, mob programming sessions.
Yes. Coding dojo. Right now.
Yeah. We haven't had a good mob programming session in a while. Actually, I think the last mob programming that we did was also building a Flask application.
You still didn't rebuild it.
Still didn't rebuild it. These are the kind of mistakes that allow anyone to, say, go up to a Mac and log in as root without a password. And that immediately dates this live stream. All right. Go back and run. There we go. There we go.
So it was the order of arguments.
Yeah, it definitely was the order. So just to show this remap, I'm curious if it will allow me to just do it on port 80, because Macs are a little squeamish about that.
Well, you need anything below 1024.
Here we go. Well, maybe I have privileges.
Oh, no. The daemon's running with privileges. Docker daemon's running.
That is true. Yeah, you do have to give your
That's why it's
admin password on install. Well, it makes my life so much easier. It's worth it. But yeah, so internally, running on port 8000, we remapped it to port 80, and now I don't have to include port number in my call.
So you're going to create a second Docker container with MongoDB, and we're going to connect to it from Flask app.
If we were feeling that ambitious.
And you can link them to the network stack, which is more efficient. It actually uses
It's a new Docker network.
No. That's the beauty. It uses like named pipes, so it usually uses the subsystems instead of going through the whole network stack. So you don't expose the ports. You actually link the containers.
Oh
So
yeah.
that way
I thought it was called Docker network.
I don't think so because it's not any type of. No, it's linking containers.
Yeah.
So you're actually.
I haven't done it myself. There's a Docker orchestration, something like that allows you to take a bunch of different Docker files, and it will create an intranet for all of those files so that they are siloed within their own private network, and then you expose just one port out of this network for your website front end.
Right, that's how it works, like logically, but internally, the interesting part is that since it doesn't run through the network stack, it's much more efficient. So it's not actually just, scripting together the ports to get for you and then creating a 192 some sort of internal intranet. It's actually saying, okay, well, I'm going to use named pipes instead and trick it into thinking that there's really a network there. So you're only exposing a single port. That's what's really cool is that it's not like, because otherwise you just do it yourself. So
That's really cool.
Those would all have to be on the same machine, right? Like,
Yeah.
You could separate your database and your application.
yes, of course. Yeah. Pretty sure. I don't think they do it in tunnels or something.
No, I'm sure someone has tried.
Well, I mean, you could, but, I meant on out of the box.
Okay. So
I have a question.
Yeah.
So a bunch of folks here working with Docker here. So my question is, if you want to have a couple Dockers running on your box, do you usually using Docker Compose, or are you using like the system that you said, or you run a couple Docker runs on your box? Just wanted to know what's best practices, what's your experience?
Our architecture team has decreed that we use Kubernetes. So we're going to use Minikube as our development environment. So that's my next adventure.
It's called Minikube.
Minikube. It's a Kubernetes cluster on your laptop.
Yeah. I mean, in the industry, you're more or less there, or you're on the full Docker stuff, which is Docker machine and Docker swarm and all that. I mean, or you're doing it by hand. Do small deployment or something.
it's really easy to get started with Docker, but a lot of Kubernetes have their own sort of tech stack, or can you take Docker containers and put them into a Kubernetes workflow?
I mean, Kubernetes is just an orchestration layer for Docker.
Okay.
So it's just running Docker images. It's similar to Docker Compose, in that you specify like a YAML file that says like, oh, I want it to use this Docker file and be built from this image, and this, that, and the other. And you can tell it like, oh, I have a Kubernetes cluster that has X, machines, and I want to deploy 8 of the application servers and 6 of the Nginx front ends, 2 database servers. And they'll just like spin it all up for you.
Right, and Docker Swarm will basically do the same thing. They're competing products, but I I would argue Kubernetes is the tech stack. Is a tech stack. It's almost that.
Very cool.
So are you guys using
What Docker? No,
Kubernetes?
Kubernetes. Oh yeah, we all suck
Personally, I don't have anything built out in my personal setup that I need to use an orchestration layer, or orchestration like Kubernetes or Docker Swarm or anything. But when working with Amazon or Azure in particular, it just makes scaling out a whole lot easier when you have everything in a container and you know it's going to run identically. Before I put it into Docker, I had an application running on Azure, and it tried its darndest to scale out gracefully, but it was using basically Microsoft's solution for putting Python applications into Azure before containerization was really a big thing, was drag and drop these files into your project and pray it works. And then if you want to update your Python version from something that's other than 2.7 or 3.4, you're going to put this plugin into through the web interface, and now your Python version isn't the system version. It's now over in this folder over here, and is way too confusing. So
we just installed Docker on every single one of our 800 servers today and deployed a Python application whose Docker file is not much more complicated than that. It's a Python application that passively reads logs and looks for certain alarm conditions and then notifies Prometheus to raise the knock of certain conditions on the CDN. It's pretty cool.
our biggest use case at work, because we don't typically have to worry about scaling out. We just need to make sure that it works for certain libraries. We have a set image on EC2 that has version 8 of NVIDIA Docker with CUDA DNN running on it. That's known good install, and anything that we need to, because we run on Macs. We all develop on Macs, and it cannot run the proper versions of all of these hardware acceleration packages. We'll just send them up. We'll put them in our private Docker repo, pull them down onto this EC2 server, and just have it run there, and just not have to worry about local drivers or anything else, because it already works. Don't touch it, and it's blazingly fast, even though it's out of network. It's wonderful. All right, so we have the basic Docker container, and it is 8.11. We could either attempt to pull something else down, or try to get, say, this container talking with another container, or try to push this up to Docker Hub and try to deploy it on, say, ECS or Azure. So what do you guys want to do?
The latter sounds pretty cool.
Deployment.
Push it up to Azure.
That can definitely do. Oh yeah.
Thing to like
They have recently hired half of the original Docker core maintainers.
I believe it, which is why I'm terrified of Docker, because it is not as, it's got a bigger ecosystem that does core. It's scary, tiny, and they have done terrible things in history. I don't know, as you move it into like production, it's been interesting. It's fun, it's great for development, but on the production side, it's terrible.
They're doing their scene.
I
can't even imagine what they're doing.
bet they are.
I kind of want to get a job there just to find out what they're
Google running off of something like Docker too. Like every time you search something on Google, it's launching a container and run the search for you and passing the result. So it's
Yeah, they
highly
use
being used in
Kubernetes.
production environment.
Kubernetes is the open source version of their internal board.
So I mean, it
Okay.
works in production. We are using Docker in production too. All of our microservices running in Docker.
Oh yeah, it definitely does. It's just most examples I've seen of it is basically designed around the concept that it will fail and that's okay. Like one of your containers will die, you have 5 of them, they'll come back in a few seconds. Nobody cares.
Fail
Well,
fast.
In financial services, safety critical systems, health services, that's not acceptable. You can't, oh, it died. No, you have to explain why it died. You have to justify why it died. You have to write in blood it will never die again. It's not the same. So it depends on, what you're doing, the workload. Because it's production ready, but then every database manufacturer will tell you, no, you can put it, but we won't support it. And there's a reason for that, I think. It's not stable enough all on its own. Like if you have one container running for one critical application. I know everybody'd say like, why would you have one container running a critical application? Just imagine that it has a workload. For some reason that workload is so critical that even if that one container dies and there's 10 others to serve the same thing, even if it can retry, that's not okay. Like it's, I don't know, my experience, and maybe it's just historical or irrelevant now, but that the containers are fragile. It's usually comes around the I/O, but sometimes it's around network.
Maybe that's
As long as you have redundancy.
maybe that's the nature of the cloud. If you put something in the cloud, you have no guarantees that you'll have something that will not fail. Maybe it's an architectural problem. You should always take into account that something will fail. It's a given. It's the only thing you have to
Right, yeah.
It's
Like I said, it depends if you have that workload that the attitude of stuff will fail. If you're a Netflix, that's cool. If you're
even for financial system. I work in fintech. It's even more so. The only thing you have for sure is that it will fail at a given point. It will fail.
you guys use Docker in production?
We were not using Docker. Just the concept of it will fail and you need to do something.
Yeah. Hey man, I suggest you recommend Chaos Monkey to your management.
We were using something similar back then.
Oh no, the Chaos Monkey is a Netflix reference. They have a system that actually goes and shuts things down.
We had this thing called a chaos provider that we use on errors. And this was like a queuing system. So microservices would go down and it would have to survive.
Oh, okay. Yeah,
So we had kept the same concept. And it was for a fintech company, payments. Highly critical. You cannot fail it. You cannot have a duplicate, etc. But because of that, we have to be prepared. So maybe
I'm gonna use you as a use
school
case.
of
That's
thought.
awesome.
Maybe it's a different school of thought.
So
Just get his number for you.
I know, right? Samples. Listen to this guy.
Generally speaking, what is appropriate to Dockerize and what's not? From what I'm hearing, you want to Dockerize something that you want to be able to scale out quickly in case instances fail, and you wouldn't need to Dockerize something like Nginx, which usually doesn't go down.
Yeah, I've been debating that one too. Does Nginx as the edge service go on the host machine, or is it also Dockerized? Because if you have a Flask application, like you're not going to front the whole application with Flask.
Yeah.
You're going to put some kind of proxy in front of it.
Yeah, based on my experience, I personally have not done this, but my opinion would be that you put Nginx outside the container because you're the biggest performance boost for using Nginx is having Nginx serve all your static content for you, and you would probably have your static content in some other location other than inside your container. So if you were building something out on AWS, I don't know where the best place for Nginx to go for deploying it, but you would put your core Flask application container on something like ECS, and then have Nginx serve your static content from S3. Because use what's optimized for what. But that is me spitballing. That's a really good question.
When in doubt, Dockerize all the things.
Yeah, I was gonna say, like, it's gonna be somebody who just says Dockerize all the things. It doesn't matter. I mean, I would think that's not enough information to make a decision. I mean, if it's part of your entire CI/CD process, then it might be easier to Dockerize it and deal with some imaging infrastructure. But you fundamentally still end up with an image because you're gonna have a Docker host and whatever that is, CoreOS or whatever it is, you end up kind of still biting some of the same problems that Docker solves. You have to solve it in some interesting way, at least. It becomes half a dozen or 1 or 6 or whatever.
Or maybe you just bypass Nginx altogether, like continuing with the AWS. Maybe you just use Route 53 and just use that on use their infrastructure.
So,
or maybe I'm.
Their DNS offering,
No.
isn't it? Talking about the Elastic Load Balancer.
Yeah, I think that's what. Oh, maybe.
okay.
I don't know.
AWS load balancer. Whatever that is.
That's what sort of what we do, assuming I'm understanding it, we have to Elastic Load Balancer components to the CS cluster.
I-
guess that
What is ECS?
Elastic Container Service, or no, like it's not Elastic, EC2 Container Service. They take their EC2 and further combine it into just an E, and now it's EC2 Container Service. It is Amazon's Docker container repository deployment mechanism, and it will just spin up an EC2 instance that's designed just to run your Docker container.
Their version of CoreOS.
Architecture. Okay, so now that we've talked a ton about
Can you show us Azure?
AWS, yes, I would gladly show you guys Azure because I personally love it for what it's worth.
Use it.
So, very quickly, I'm quickly going to go in here instead of, well, yeah, let's just do it. Okay. Just made a quick change. Let me double check the requirements.txt. And just to make things simple, I'm going to set this onto 80 just to keep my sanity in check here. We'll rebuild it. And notice it went back. I changed expose 8000 to 80, so it's going back and rebuilding all the pip stuff. All right. So, at least from the Mac side of things, they have this Docker daemon that's running, and I'm already signed in to my personal account. So I can just do Docker push. Oh, actually, I need to do this first. Go back and build, and I put my username with a hyphen, and just for the purposes of demonstration, this is the total container and tag that it will actually be pushed up as, but there we go. Nothing changed except the tag name. So I'm going to do Docker push my username and then the container DockerPy, and it's going.
Docker
it's going to, yeah, this is pushing up to Docker Hub.
It's pushing each layer separately, right?
Yeah. Or yes, it's pushing up each layer. So whatever the core images were on, and then the second highest layer, well, the second one is going to be the Python 3.6.2 to double check it, and then finally our individual container. In the meantime, while that is finishing, because I think it does a check on itself, let's go over here to, actually, let's go over here because I think it was already up, Docker Hub, and I can go over here, my profile, private repository, yeah. And here's our Dockerpy. For the purposes of Docker Hub, you get one free private repository, so they don't limit you like GitHub. Yay. And you can have an infinite number of public repositories. So add your description, your tags, double check the tag. It should just have one in there, which is latest. If it loads the page, there we go, there's latest. Compress size and last updated. You can share, collaborators, all of that fun stuff. Come on. There we go. And if you want to get this on your machine, all you'd have to do is this. It'd pull down exactly what we've done, and it's now on your computer. So we can use this by going into Azure, portal.azure.com. I should already be logged in. All right. So you can go to new. Now let's see if I can remember all of this. I think it's web. Let's just search for web container and see what comes up. Web app for containers, I think is what we wanted. Yes. So, web app for containers, create. Oh, let me make this page bigger. So I'm going to call this OPUG. Configure container. And we go in here. Repository access, it is public. If I was using a private one, I would need to use my username and password in order to access it. Docker Hub, Azure Container Registry, or something else. So if you had something like an enterprise level Docker registry or container registry, you can also use that. But all we need to do here is, instead of doing Docker poll and giving it, I just do the same kind of thing. My username and then Dockerpy. And I'm not sure if they play well, so I'm just going to say tag is latest. Okay. And then we wait for it to spin up. And hopefully there shouldn't be anything else that I need to do. Hopefully. I did have to debug this one, which was the application that I upgraded or put into the Docker container. opug.azurewebsites.net, and it probably is not going to come up as soon as I click it because it takes a little while for the server to spin up load the Docker container, and then have it deployed. But when it does, it will be right there. Has anyone, I'm sure some hands, has anyone never seen the Azure Portal before? That's what I figured.
What's the pricing like?
The pricing for, you can, my web app that I'll talk tons about if you want me to, costs $45 a month to run. Has dynamic scaling out to up to 10 different servers. If you want to see actually the scale up, everything's based in an app service plan, and these are the basics that you get. There's no free tier for container applications currently, but they have free tiers for basic web apps where you have to upload your code as is instead of a container.
Any discernible reason, at least on the Azure, to run this as a container? Like if you could run as a function.
If you could run, personally, if you can get away with, well, if you only need a function in order to process what information, absolutely do a function. Or on AWS, it's Lambda, all these kind of things. If you just need something that's stateless, please use it. It's so much easier. But
it seems so similar because a lot of Docker containers have been stateless apps.
yeah,
Mostly stateless.
unfortunately, a lot of stuff that I made is very stateful to some degree, or just needs more resources and libraries than a function can handle. But yeah, if you can put something in a function, there's no need to go through all this.
Ultra dumb question here. There's no persistent storage on functions.
It has access to persistent storage and other mechanisms, so your functions or your Lambda can access a database, and there you can use it stateful, but no local stateful, or and no full-time applications, or like a full Flask app.
But you can have like an object store as a volume, I think, and then that could be mounted as a file system, and you can basically.
I don't
know. If
Intuition tells me no, but I haven't tried that. I haven't looked into that, so I can't give a definitive answer on that. There is an interesting project called Zappa that takes your Django, Bottle, or Flask applications and at least attempts to put it into Lambda for you. It's interesting if you can get it to work. It does not play well with Anaconda, unfortunately. And you must be running things inside of the standard venv, virtual env package in Python. But if you're already set up like that and you can get it to work, then you can absolutely take the application that we wrote here, or in theory, any Flask application, and it will magically make it stateless for you. Yeah, so.
Should we see if it came up?
Yeah. Anyway, this is Azure. It's just, it just looks different, honestly. Azure and AWS have a lot of overlap. Let's see. opug.azurewebsites.net. Hello world from Orlando Python. Our container is now deployed and on the World Wide Web. Ta-da!
Can you write using Docker run like the 8,000?
Yes.
How does it know?
Oh, so quickly before I went back, I went and changed port 8000 to port 80 in both our expose and our run here. And so it automatically opens it up. I believe we could go through the settings and find where the port mapper would be for your application. But if you just make things port 80, if you make the website port 80, then it's automatically available. I know that you can do the same kind of port mapping in both here and ECS, but I don't remember offhand where that is. So yeah,
You probably have to change the firewall rules and all that.
I think that's more or less where it lies. But yeah, I can go through the Azure Portal and say, hey, this is cool. If anyone wants to take a look at it when we are finished, by all means, come over. I will erase this container when I get home, but you guys are welcome to look over it if you want. And anyone who goes, anyone right now in here or on the live stream who goes to opug.azurewebsites.net can get this friendly little message for themselves.
I can attest to this one on my phone.
Yeah.
It works.
So, basics of Docker. We created a Docker file, use it to wrap a Flask application, push it up to Docker Hub, and made it and deployed it on Azure. That is actually a bit more than I thought we were going to do, and this is wonderful. So, question time, or I guess before we get any questions and break, I would love to thank Tops for giving us this awesome space, and definitely hope to see you guys, throughout all next year and a year after that, and as long as I'm here.
It's a great presentation. So we could.
Yeah. So Orlando Python is on the 4th Tuesday of every month, which means we do not have one in December because I do not want to do that to you guys. So our next one, whatever the topic is going to be on, we're always looking for new topics. I happen to be using Docker a lot lately and knew a lot of people were interested, so that's how this came about. As you can tell, we can either have presentations Orlando dev style, or just kind of pull things out of the rabbit hat like we sometimes do here like this, and whatever the format is, if you want to give a talk in the future, or just lead a discussion or a round table, open to anything that you guys want to come here and talk about, Python related. With that, any Docker questions, any Orlando Python questions?
I do have, maybe you could give me just a really, really, very watered down example, but for what I do in data science, right? What's a scenario where I would want to use a Docker container? Can you just give me a quick?
Ooh, data science.
I mean, our data scientist was the one that deployed the Docker container today.
Okay.
So he's analyzing logs on all of our edge nodes and then looking for trigger conditions and then communicating those back to the center
Okay.
using Prometheus.
That's just as an example.
Yeah, so we have lots of servers generating lots of machine data.
Okay.
Most of it's noise. But he wrote a Python script that analyzes that log and looks for signal in the noise and then raises a flag when interesting data arises.
Different Docker container. Put
The
it
same
in the
Docker
same
container on 800
So
servers.
he added to all of the Docker containers that you have and deployed the new ones.
Yeah, he put it in our company's enterprise Docker registry, and then that Docker run command was run on all of them, so they all downloaded it all at the same time. Spun it up. The log was already there because it's a service that's been running for years, and just started passively looking at the log and alarming on interesting things.
So you guys ignoring some logs on the box and just indexing some of them, not all the logs on the box.
Yeah, so we're not trying to take the entire fire hose or even an aggregate of that data and communicate it back. We're just looking at the data as it's filtering through and looking for interesting things.
That's interesting.
And then he has certain alarm conditions, and then those get sent as events to Prometheus.
Something else I can think of for data science, you can share your results in Jupyter Notebooks.
Mm-hmm.
So here's this. Here's the code that generated this output, and then you talk about it. You could use Docker containers to not only share. Here's the notebooks. Here's the actual environment that I ran it in,
Okay.
and you could share out the entire environment, libraries and all, and say if you want to, you can go through, empty the Jupyter notebook, and run the entire thing from scratch, and you will get the exact same results that I did.
Okay.
So that could be another
Thank you.
really useful thing.
Every data scientist also has their own like favorite set of tools.
I know.
So if you can write like your Docker file,
Yeah.
then like you can share that out with your other data scientist friends.
Okay.
And then also like every developer's worst nightmare is getting a new laptop. Set everything back up again. You can just run that Docker image and your
Okay,
entire
that's
environment's already there.
Yeah, you get your Docker account. You say here's a Docker container with all of the tools that I really want to use. You push it up, and then if you go on, you can go on any computer that has Docker on it, pull it down, and go, I'm at home again.
Yeah.
Okay. All right. Thank you. Those are great examples.
No other questions? Thank you guys for coming out, and hope to see you in January.
Thanks, Mike.
Are you not having one stage?
No. We actually last year we actually had one the first Monday of December because the Tuesday in the last Tuesday in November was too close to Thanksgiving, and then the last one came right next to came right next to Christmas, and so instead of just skipping both of them because we knew no one was going to come, we decided we're going to put this really early in December when people could at least show up. Yeah. All right. So I'll go ahead and stop this guy.
Anybody interested in working in tops, please talk to us.
Do you have a restroom?
Yeah, it's here. First door after the